It's been a while. I know it's been a while with the fair break. All right, quick review. We've talked about isomers in this chapter. First, we talked about how to name things. We know how to do that, hopefully, by now. Like, for example, if you look at this guy, what is he? I've got a lot of different models up here because I ran out of, well, okay, it's pentane, right? So this guy's pentane. We would all know how to name him. Now, what kind of an isomer is it, and what is he called if I do this to him? If I have to actually break some bonds and rearrange it and give it a whole different name, what kind of an isomer is this? He's no longer pentane. What is he now? Look at him. What is he? Well, he's not just butane. It's 2-methylbutane, right? 1,2-methylbutane, right? What kind of an isomer is that? It's been a while. Those are the first ones we talked about. Those are structural isomers, right? Where they have a same exact formula. I didn't lose any H's. I didn't lose any C's. But they're not the same compound. They have different properties even. So that's the first ones we talked about. Then we talked about these kind, where I have to look at them a certain way. And if I look at them this way, these hydrogens are pretty much all lined up. What do we call that? When they're all lined up. Come on. Wow. Well, the test is this week. You better get it soon. How about like that, when they're like this? That's, well, it is more staggered, right? And the other one is eclipsed. Okay. What kind of isomers are these? These are just rotating about the carbon-carbon single bond. These are conformational isomers. They're the exact same compound. This guy, completely different compounds. These are the exact same compounds, just in a different conformation. Then we talked about really weird guys. Guys like this, who have exactly the same guys bound around the carbons, but they're not arranged the same way. All right? Stereochemically, they're different. They are mirror images of each other, like your hands are mirror images of each other. We call them... Wow, it's been a long break. It's been a week. What are they called? Well, these would be diastereomers. If I have one that is the same and one's not, I can have diastereomers. I have to have 2 chiral carbons. But if I only have one and they're mirror images, they're called enantiomers. Okay. All right. So that's a lot. This is going to be, look, this is not easy stuff. You know, and we've got one more to get today. All right. And the last one we're going to get has to do with if you have a double bond. Now, both of these guys are basically the same. If I look at this guy, if I were to draw this guy on the board, which I will in a minute, he would be, if you look at him like that, what is he? It's a double bond here with the thing. What would he be? 2-butene, right? Everybody agree? Okay. And this guy also is 2-butene, correct? 2-butene. Problem is, if I look at him this way, the chain, the carbon chain, the butene chain, goes across the double bond for this guy, but it's on the same side of it. You say, well, that's so what? I mean, with this guy, I could just rotate one to the other. But with the double bond, you can't do that. You cannot rotate this guy. All right? So this is actually different than this guy. And they actually have slightly different properties. All right? And it does make a difference with a lot of things you're going to find out. For example, even in your body, most of your amino acids have existed 2 different forms. Okay, I'm sorry, that was for the enantiomers, diastereomers. But for the main reason you see this, they're called cis and trans. What do we see trans? Where have you heard that word before? Trans. It's in the health stuff all the time. Trans fats. Yeah, trans fats. You haven't heard about trans fatty acids, trans fats? They're on every package you probably buy. And that's, by the way, yet another, let me go off on another digression here of my, the way you guys are, bamboozled by stuff. It's not you. It's what the market. You guys ever watch Mad Men? You ever see Mad Men? I mean, that's what people do. That's what advertising people do. They latch on to a catchphrase and they make you buy something based on that. So even food that never had any trans fats in them now have huge labels on them saying trans fat free. Because, it sounds like, oh, and that's a good thing. We'll put that on our label and people will buy it. Well, they never had it to begin with. All right. I mean, it's just amazing how people, we buy into this nonsense. Oh, great, that must be healthy now. Now I can eat all the chips I want because they don't have trans. Well, they still have a lot of other crap in them too, and the other kind of fats aren't exactly great for you either. But yeah, we'll talk about that. That's what the article's on, trans fats. Well, that was a long intro. You guys had a very long break. I hope you enjoyed it because you obviously didn't do any chemistry over it. Let's talk about geometric isomers. All right. I'm going to draw them two different ways. Did I give you one? I gave everybody else one. How did you not get one? Were you not here? Geometric isomers. These guys are stereoisomers. Technically, they're stereoisomers, but they result from incomplete rotation about a carbon-carbon double bond. Now you can't see, just like you can't see stereoisomers when I draw them only a certain way. I have to draw, especially like enantiomers, diastereomers, I have to draw with wedges coming out at you. You can't even see conformational isomers unless I draw them with using the Newman projections. Well, these guys too, I mean, you kind of have to draw them and emphasize which one they are. So, for example, I can have two possibilities for 2-butene, the one I just showed you right here. Okay, that's my first example. I'm only going to do about 2 or 3 examples. This is way easier than any of the other ones I think that you've seen because it's very simple to see it. We could have that. You could draw this guy, CH3C. Draw him, and you can have, and he's called, by the way, trans 2-butene. And you can have this guy, and you can see the obvious difference between them, right? I would hope. And I'll show you with the models again in a second. That's called cis 2-butene. And you have to figure out how to remember this, because you're getting a lot of stuff to remember. And obviously, you're having a hard time remembering some of these things, just from judging by the questions in the first part of the class here. So you got to have little ways to remember this. And again, I always emphasize this. Use your prior knowledge. You know what trans means. Where have you seen the word trans before? In what kind of language, what kind of parts of the language, where do you see that? Give me another word that uses trans.
Translate.
Okay, that's actually true. Yeah, I wasn't thinking of that. I was thinking of, like, your railroad. What kind of railroad did you learn about? Transcontinental railroad, right? What about a flight, if you're going over to Europe? Transatlantic flights, okay? What is trans, and even for translate, what does trans mean? Transatlantic. It's amazing. Transatlantic, transcontinental. What are you doing?
Going across.
Across, yeah. So across, the chain goes across the double bond. Trans 2-butene. Cis, I mean, you don't know what cis, I think it comes from like something Latin. But for us, we can remember because cis starts with S, and they're on the same side. Cis, same.
Cis does not start with S.
I know, it sounds like S, though. I know. It doesn't start with S, but it sounds like S. So the same side. So that's how you remember it, right? Cis, same, trans, across. All right, well, again, and here they are. I have this guy, like, when I have him, like, there's my model of him. I can't just rotate. You say, why can't I just rotate one into the other? Because of the double bond. If it was a single bond there, absolutely it could, but it doesn't. It's not, so it can't. And it wouldn't be wrong. Look at how I have this guy drawn like this. Is he the same compound if I just flip him around like that? Sure. It doesn't matter how I draw him. Okay? If I have the... But I have to draw it correctly. It's an amazing thing. That's why I'm going to do about 3. I found out after doing this, I thought, boy, these are pretty simple. And I do like another example. And then sure enough, first worksheet I give you, and on the test, people are making all kinds of crazy, crazy mistakes. So by the time we get to the end of the examples today, hopefully we'll have corrected those. So let's do a couple more examples on the next page here. Oops, I need a blank page here. Hold on. I'm going to make one. There. Let's draw this guy under example 2. Oops. All right. See if you can tell me this guy's name. And you got to use the same rules you learned from before, okay? Okay, so draw that guy under example 2. And I'm probably going to draw more than just 2 other examples. I'm probably going to draw maybe 3 or 4 other examples because I found these mistakes. And I've got quite a few written down here to try to get them out of you. Try to pull them out like teeth. What would you call that guy? Everybody put your own name down underneath him. Because if you're not practicing these, hey, the test is Wednesday. You know, when are you going to start? It's not like you could just, I'll study for this. This is not really a test you study for. This is a test you know how to do the stuff. You know how to name these or you don't. Yeah, there's a few things you got to memorize. I got to know all the prefixes and the suffixes. I got to know pent, hex, but, meth. I got to know what they mean. And yeah, there is some memorization. But basically it's about knowing them. It's about understanding them, not just memorizing them. So if you can't do these now, when are you going to start? Most people will get this one right, I would think. The first mistake, a possible mistake you might make, is naming it from this side, thinking, well, the bromine's closer to that side, and it is. But the double bond is closer to this side, and double bonds take precedence, as you should have learned from the first rules you guys got back 3 weeks ago when we first did that on Beaker, right? Remember that? So I have to start from this side because that's where the double bond is closer to. 1, 2, 3, 4, 5 bromo. 1, 2, 3. Not 3, sorry. 1, 2. Is this trans or cis? Cis, 3, 1, 2, 3, 4, 5, 6, 7. What's 7? Heptene. Okay. So 5 bromo, cis, 3 heptene would be the correct answer. The 3 goes after the cis and before the name of the parent chain. Okay. So you have little mistakes there. You might think, well, that's what he was talking about. All right, I understand now. I just put the 3 in the wrong place, or I did it from the wrong side. No. Actually, I'm talking about dumber mistakes, ones that you're going to make when you're doing them backwards. For example, why don't you try drawing this guy? I want you to, well, first we'll name this. We'll do one more naming, one more this direction. Looks like to me. So draw this guy. And let me just keep a clean board and just make it easier. I would put him, you have room probably right over to the side here, right? Put him over there. Okay? What's that guy? Draw him first. Try to name him. What's that? No, they're all C's. They're all C's. This is an F. That's a CL. Other than that, they're C's and H's. I'm going to use this one after you're done. I'm going to use this one to try to illustrate for you how you would use the same, because we're going to have to do this tomorrow in the review anyway. The same basic pattern you're going to use to name any compound. That's going to be a large part of this test, people. The whole first page is going to be just naming compounds like you had on that pre-test, I would call it. The one that was worth 40 points, way back when you used your own rules. I gave them back to you afterwards. That was all naming. Well, the first part of this test is going to be naming. So let's talk about this. I mean, what I would do when I'm naming something, basically I always want to find, first thing I want to find is what's the longest carbon chain. And that applies for these as well. What's the longest carbon chain here? It is not 1, 2, 3, 4, 5. So if the last thing you have written is pentene, you're wrong. What's the longest chain? 1, 2, 3, 4, 5, 6. Whichever way you go, up here or down there. 1, 2, 3, 4, 5, 6. The last thing I'm going to write is going to be, and is it cis or trans? All right, so it's going to be 1, 2. Last thing I'm going to write is going to be trans 2 hexene. Right? That's what you should all have for your end. And remember, the nice part about chem versus history, biology, most other classes, except for math. The best part about chem and sciences, most sciences, is that I can give you partial credit. If you get that much right, you're getting some credit. Now, you could get something else wrong. All right? But hopefully you had to go from this side, even though there's stuff more close to that side. So we wanted to go to this side because the double bond takes precedence over that fluorine and chlorine and methyl. All right, now, let's go name these other guys. What do I have here? 1, 2, 3. And I won't care about order. Like, for example, should you name the chlorine before the fluorine because alphabetical? No, I don't care. As long as they're on the right carbons, that order I care about. So you can't call him 1, 2, 3 chloro. That would be wrong because I started from this side. But I don't care if you name chloro first or fluoro first or the methyl first. It doesn't make any difference to me. So 1, 2, 3, 4 chloro. Oops. 4 chloro. 1, 2, 3, 4 fluoro. 1, 2, 3, 4, 5 methyl. Trans 2 hexene should have been the correct name, right? Now that pretty much summarizes what you did, with the exception of this one word, trans. It summarizes what you did the first week when you were back on Beaker using the computers to try to figure out how to name these. And this is a large part of that test on Wednesday. It'll be at least the first page, but it'll also show up in other places on the first on the test as well. But that'll be at least the first page, just naming compounds. All right, now let's get to some really crazy ones. You have room down below. I mean, don't go by the example numbers. I told you to put that one over here. Now this one over here says example 3. You can call it example 4. It doesn't really matter. Try drawing them backwards, and here's where I found the biggest mistakes. Right now, everybody seems to understand trans and seems to understand cis, and I've spent some time reviewing with you naming, so you're okay with that. So let's try drawing a couple things. Try drawing 3-bromo, cis 2 pentene. Try drawing that guy. And I'm going to I need you to actually draw this guy because I'm going to walk around and see how many got it right. I need you to actually draw this guy. So everybody draw it, and I want to take a look at it after you're done. So far we're at 50%. Going down from there. See, move your hand. All right, we're back up to 50%. We're a little above 50%. We're back to 50%. We're back above 50%. We're back to 50%. We're above it by a little. We are back down. We are back down below. We are way below. We are way below. We are getting closer and we're a little bit better. But we did not get 50% right. And the amazing thing is, most of you have 3-bromo, 2-pentene drawn correctly. Most of you. I saw 1 or 2 mistakes even for that. But the way you drew cis was wrong. You said, well, I know I didn't. Almost everyone bent the chain, you know, with the cis being same side. But you drew your hydrogens or your bromines backwards. Exactly. And you said, well, that's no big deal. Yes, it is. Let me show you what I mean by the mistakes I saw. Don't draw this. All right? First of all, what would cis 2-pentene look like? Well, I mean, there's a couple of ways you can draw it, but I mean, you might draw it like this. All right, 1, 2, 3, 4, 5. I saw actually somebody just drew 4 instead of 5. That would be one way you could draw it, but let's face it, that's not the only way. You could draw it like this. And that would be correct, right? And they could actually just as well be this. Couldn't it, right? They'd all be cis 2. However, here's the mistakes you people made. And it was over half of you, well over half, did some version of this mistake. You went and put your stuff on, 3-bromo, 1, 2, 3-bromo. Hopefully you put it there. But then you put your H up there. Well, you drew the H and the bromine trans, but you drew your chain cis. Or you put no H's at all around it. That's backwards. You can't do that. The correct way is this way. This way, these guys are cis and the chain is cis. The rest of them you just fill in normally. All right? And that's what over half of you did. You drew, this is the correct answer now. You can copy that down if you have a mistake on it. The main problem that most of you did was you did not put your H's and BR. In other words, the chain was drawn cis, but the other things were drawn trans, or not drawn at all. Or drawn, and I always love this one. This is my favorite. I did see one of these, and I'll see more of them. Okay? People who do this, they'll draw, they'll put a dope on there, and they'll bend it somewhere else. I mean, I don't understand that at all. Where does it obviously have to bend? At the double bond. I mean, they'll have like this. I mean, I don't understand that. It doesn't make any sense. I mean, they just bend it here for no apparent reason. It has to bend, obviously, at the double bond. Other than that, you know, the hydrogens can be rotated any way they want to. The only place it's stuck in one or the other position is at the double bond. All right? Let's try one more drawing one, and then hopefully you'll be able to get this one right. Although this is a little bit bigger, so we'll see. Try drawing this guy. 2-fluoro. Trans 3-hexane. It's not that much bigger, actually, I just realized. I'm not going to walk around and look at everybody individually here. Hopefully you're drawing them correctly, but I'm going to put the correct answer on the board. And the first thing I would do is draw the trans 3-hexane. All right? And again, there's more than one way to do this, but 3. At the third one, you're going to have a double bond. All right? And then I've got to put 6 total, so if it's trans, the chain's going to go across it. So 1, 2, 3, 4, 5, 6, right? 3, good. Where do I put these H's around here? So I put them, I love this. People will put them trans like that. Did anybody do that? that is trans. It makes absolutely no sense because we know things repel each other. They're obviously not going to be on the same side as the chain. They're going to be on the opposite side, like that, right? Okay. Now, where does the 2-fluoro go? Well, where could it go? Could it go here and be right? Could it go there and be right? Yeah. Okay. And then the rest of them just fill in. Got it? Now, would it be wrong if you drew it, flipped upside down, or with the floor in here? No, there's a lot of ways I could draw this correctly. You don't have to erase it and draw it exactly like that. But that's the correct answer. All right? Okay. Well, I've got a worksheet.